In this video, we will talk about how to measure the error of a forecast to see how well the forecast is performing. And you'll remember when we did the first lecture on forecasting, we mentioned these three methods. First is the MAD, then there's the mean absolute deviation, then there's the mean squared error, and then there's the mean absolute percentage error. And they all work on this, start from the same place. In every period, we take the actual minus the forecast. For the MAD, we take the absolute value and sum them up and divide by the number. That's just taking the average of those values. The mean squared error, we take the errors and square them and take the average. For the MAPE, the mean absolute percentage error, find that error, divide by the actual to get the percentage error, and then take the absolute value and take the average and then multiply by 100, so you get a number like 62.5% average error. I thought to demonstrate this, we should go back to the spreadsheet that we made in the video where we were doing forecasting with a trend and seasonality. So if you recall, in that video here we're looking at the actuals and the forecasts, and you can't even really tell which is which because they match each other so well. So what I've got here is I have each of the periods, and then we have what actually happened, and then we have the forecast. So what we need to do each period is calculate the error for that period, which is the actual minus the forecast. And obviously that could be a positive number or a negative number depending on whether the forecast is bigger or the actual is bigger. So we get the error for each period, and then what do we do with that? Well, like we just said, one thing we can do is we can calculate the MAD over the whole series of data points. So where we can let, in this case, t will go from 1 to, we have 20 data points, so we'll go from 1 up to 20, and every period we will take the actual minus the forecast, we will add those all up, and then that whole total we'll divide by 20. So for example, in the first period we have the actual is 9, and the forecast right here was 8.29. So we get 0.71 as the error for the first period. You can see in the second period the error is negative. If we add those all up, they add up to they add up to got ahead of myself. We have to take the absolute error, take the absolute value, and if we add those up, so if we sum these numbers right here, they sum to 15.76. So we get 15.76, which we divide by 20, and we get 0.788. So our average absolute error is 0.788. Then one of the other things we will use to see how well this forecasting method is working is the running sum of forecast errors, where we take the errors for all 20 periods. So t goes from 1, oops, that's not a 2, 20, And then each period we don't take the absolute value, we just find that error term and add those all up. And that's what I've calculated right here. Summing those terms up, the running sum of forecast errors is in this case negative 0.63. So then the next thing we're going to do here is calculate the tracking signal, which tells us whether on the whole we have too many positive errors and too many negative errors. The running sum of forecast errors, of course, tells us that on the whole we can see that because it's negative, switch to red here, because it's less than 0, it means that on the whole the forecast must be bigger than the actuals, which is fine, that can happen. The question is, are they too much, too negative? So to get the tracking signal, we're going to take this running sum of forecast errors, so negative 0.63, and we will divide by the MAD, 0.788, and we'll see what that is. Minus 0.63 divided by 0.788, and we get negative 0.799. So the tracking signal, the way we look at it is if it's less than 4 and it's a bigger number than negative 4, then things are okay. And since this is definitely between that range of positive 4 and negative 4, seems like our tracking signal is working pretty well, which means our forecasting method is working pretty well. So here in Excel you can see where I calculated the tracking signal. If you round it to 2 decimal places, you just get 0.80. So our forecast seems to be working really well. And if you look back at the data, they do fit very closely. Sometimes one is higher than the other, and sometimes the other is higher. So seems like it's working very well.